Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Reading graphs. This video will help you read a circle graph, read a bar graph and a line graph, and also construct a histogram. Read a circle graph. Let's start with some definitions. A circle graph is a graph in the form of a circle that is divided into pie-shaped pieces where each piece represents one part of the data set. The entire circle represents the whole, or 100% of the data set. The sectors of a circle graph are the pie-shaped pieces that represent each part of the data set. Let's take a look at an example that will help you understand how to read the information on a circle graph. Example 1. What percent of the students are studying manufacturing? Well, we want to know what percent of the students are studying manufacturing. So remember, if we're going to write this as a percent, what we need to do when we want to write something as a percent, we want to represent the part over the whole, which in this case, when we're talking about the percent, we want to know the students that are in manufacturing and then the whole is going to be all the students at this East Community College here, which is going to be the total students over the total students. Well, it's going to take a little bit to find the total students, so let's work on that first. To find the total number of students at this East Community College, we are going to have to add all of these things together. So starting right here, let's go around and add up all the number of students at this college. So we would say 3,000, and then 4,700, and then 1,100, then 500, and then 700. So we're going to add this all up, and when we add those all up, we get 10,000 students. So there are 10,000 students there. So let's take a look. Our percent then is going to be the manufacturing students. Well, if we're taking a look at our circle graph here, here's manufacturing. That's the blue sector of the pie graph. And so here is the blue sector of the pie graph. That's 1,100. So we would say 1,100, and we're going to divide that by 10,000 students to get a percent. So on some scratch work, we're going to do we're going to take 10,000 and divide it into 1,100. When we do that division, we're going to get a decimal answer. We're going to get 0.11. So let's see. So after that division, we get 0.11. Now, that is a decimal number. We need to turn that into a percent. So remember, to turn it into a percent, we move it 2 places to the right. 1, 2. So the percent of students that are studying manufacturing at this East Community College is 11%. Now it's time to check your understanding of reading a circle graph. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. What is the ratio of computer technology students to transfer students? So if we want to write this as a ratio, this is a ratio that we need. We need the computer tech first, and that goes in the numerator of our ratio. So computer tech students to transfer students. That's the way we want to set this up. Let's go ahead and take a look now and find this information in our circle graph. So the transfer students are the students here with this green, so that is 3,000 students. That's going to go in the denominator of our ratio here. And the computer technology students, that is the purple there, so that's 700 students. Okay? Now, we want to write this ratio in lowest terms. We don't want to tell somebody the ratio of transfer or computer tech students to transfer students is 700 over 3,000. We got to simplify this. So what we're going to do is we're going to look for a common factor. And with all these zeros on the end, that makes me think I'm going to want to divide out either a factor of 10, or in this case, since there are two factors of 0, in each of these, I'm going to divide out a factor of 100. So I can write 700 as 7 times 100. And I can write 3,000 as 30 times 100. An easy way to make sure this is correct is to make sure I have the right number of zeros. Notice there were 2 zeros in 700, and I have 2 zeros here when I factored that. In 30,000 there were 3 zeros, and I have 1, 2, 3 zeros down here. So I factored this correctly. And now you see that I got a common factor of 100 I can divide out of both the numerator and denominator. So I divide that factor of 100 out, and I get 7/30ths, and that's in simplest form. So the ratio of computer tech students to transfer students is 7:30. Read a bar graph and a line graph. We'll start with some definitions. Bar graphs are useful for making visual comparisons of data. So whenever we want to compare one thing to another or a couple things all together, we typically use a bar graph. Line graphs display data points that are connected by lines and show a trend. So we usually use line graphs to show a trend over time. So when something's happening over time and we want somebody to see what trends are happening, we usually use a line graph to display that data set. Now let's take a look at an example that will help you understand how to read a bar graph. Example 2. Determine how many gallons of gas it would take to drive the Ford Escape Hybrid 380 miles. Round your answer to the nearest gallon. Alright, well let's take a look. First let's identify the Ford Escape Hybrid. Right? So here is the Ford Escape. And we have two things in our bar graph here. And over here in our legend it tells us the hybrid is the purple one. So here it is, getting 34 miles to the gallon. And that makes sense that the hybrid would get more than the standard. So if we were to write this as a ratio, we would have the ratio 34 miles to 1 gallon of gas for the Ford Escape Hybrid. Now what we're asked to do in our question here is to find out how many gallons it will take to drive 380 miles. Well, we can set up a proportion to solve this. We could say 34 is to 1 gallon as 380 miles is to X gallons. We don't know how many gallons, but we could use this proportion to figure that out. Alright, let's take a look. Looks like our variable is in the denominator here, so we want to flip both sides. So on the left I would say 1 is to 34, and I'm going to drop out all of the units of measure here. That would just complicate our solving. So I would say 1 is to 34 as X is to 380. And now I want to get X all alone, so I'm going to multiply both sides by 380. Over here I'm going to write 380 over 1. And on the left side I'm going to do the same thing. 380 over 1. You can see the common factors of 380 divide out here and here and leave us with just X. Let's come over here and figure this out, and I'll finish this up. So on the right side we had X. On the left side I have this 380 over 34, and we could factor this to get us close to the answer, but notice they want us to round our answer to the nearest gallon, which means we want a unit right here. We don't want to have a fractional answer. We want to actually get a decimal. So we're actually going to do this division even though it's not going to work out evenly. So on some scratch work here, we're going to take 34 and divide it into 380. And when we do that division, we are going to get 11.17. So 11.17. And now they want us to round that to the nearest gallon, or nearest whole number, which means this 1 is going to tell us that the 1 in 11 is going to stay the same. So we actually get here that this thing is 11 gallons, and that's an approximation. Let's say an approximation there, that it would take approximately 11 gallons to drive the Ford Escape Hybrid 380 miles. Now it's time to check your understanding of reading a bar graph. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 2. Determine how many gallons of gas it would take to drive the Toyota Camry Standard 250 miles. Round your answer to the nearest gallon. Well, let's take a look at our bar graph here. We got the Toyota Camry right here, and the Standard is the vehicle here that's kind of the brown bar. So our brown bar there is 28, so it looks like 28 miles for 1 gallon of gas. So there is our first rate. And now we want to know if we got to go 250 miles, how many gallons is that going to take? So we have X gallons there. Okay, looks like X is in the denominator, so we want to flip both sides to get it in the numerator. While we're doing this, we'll get rid of all the units of measure. So we're going to have X over 250 on the right side. On the left side, we're going to have 1 over 28. We're trying to get X all alone, so we want to undo that division of 250. So I'm going to multiply this side by 250 over 1. The left side, same thing, 250 over 1. Common factors of 250 divide out and leave us with just X. On that left side, it's a little bit trickier. We're going to end up with, actually let's come over here a little bit. We're going to end up with 250 over 28, and that is equal to X. And so again, we're going to have to do some division here to get this down to a unit rate, so we can find out how many gallons this is going to take. So we're going to come off on some scratch work, and we'll do 28 into 250, and when we do that division, we get 8.92. And so we're rounding to the nearest gallon. That 9 then is going to tell us to round that 8 up to a 9. So it looks like here it's going to take 9 gallons of gas, and again that's an approximation, approximately 9 gallons of gas to drive the standard Toyota Camry 250 miles. Now let's take a look at an example that will help you understand how to read a line graph. Example 3. By how much did Dan improve his race time from the first race to the third race? So it looks like he's running a 1 mile here. He's got some times listed. Here's his first race. It's a little bit above 5:31 in the line graph here, so I'm going to kind of estimate that to be 5:32. We don't have to be exact since we don't have an exact number there. We're just going to kind of guesstimate. Do our best here. Let's see, improve from the first race to the third race. So here's the third race, and it looks like just a little above 5:02. So I'm going to say that that mark on the bar graph is probably 5:03 or 5:04. I'll use 5:04. So let's see, we want to know by how much did he improve his race time. So it looks like we're going to start with 5:32, and we're going to subtract from that 5:04. And so let's take a look. We'll have to borrow from the 3, which will make it a 2, makes that 2 a 12. 12 minus 4 is 8, and then 2 minus 0 is 2, and 5 minus 5 is 0. So it looks like he improved 28 seconds between the first and third race. Now it's time to check your understanding of reading a line graph. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 3. Between which 2 races did his race time improve the most? Well, let's take a look at the races in the line graph. So here's his first race, here's his second race, third race, fourth race. And we want to talk about improvement, so that's a decline in the graph because times are going down. So it's either going to be here or here. And you can tell, since this line is longer in the second case, that that's where the most improvement happened. So we would just say between the second and third race, he improved the most. Construct a histogram. Let's start with some definitions. A histogram is a type of bar graph that shows the frequency of data in class intervals. The number of data entries in each class interval is the class frequency of the data interval. Now let's take a look at an example that will help you understand how to construct a histogram. Example 4. Construct a histogram for the grades in this history class. And you can see we've got the grades listed here. And I've already organized these from least to greatest. Typically, the grades would be all scattered about, and most of the time when you see a data set when you're creating a histogram, It'll be all scattered about, and the first thing you'll have to do is organize it from least to greatest. But it's already been done for us here in the example. And now what we want to do is we want to kind of tally this up into class intervals. And in this case, since we're talking about grades, it makes sense to go by class intervals of 10. And you can see we've started out with the smallest class interval from 50 to 59, and that's typically a not passing or a failing grade in a class. The next class interval again goes by 10, 60 to 69. Notice there is no overlap between these intervals. We go right from 59 to the next one, 60, and then from 69 to 70, so on and so forth. So we've created all of these class intervals, and now what we want to do inside of these class intervals is tally up the number of scores that occur in each of these intervals. So let's start with the lowest one. Between 50 and 59, we have 2 scores. So we would just have 2 tally marks there. Now going with 60, we have 1, 2, 3, 4. So 1, 2, 3, 4. And then in 70 to 79, 1, 2, 3, 4. 1, 2, 3, 4. 80 to 89, in this history class, we have 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Typically, sorry, we usually put the 5 across like that. So there's 7 of our tally. And then in the 90s, we have 1, 2, 3. So 1, 2, 3. All right, now the class frequency is what we just got done tallying. So in each side of class interval, here are my class intervals again. In each of these class intervals, our tally tells us the class frequency of that class interval. So starting again with the lowest one, 50 to 59, our class frequency was 2. 60 to 69, it was 4. And then 4 again, and then 7, and then 3. Now, these class frequencies help us create now the histogram. So let's come down here and take a look at our histogram. So down at the bottom, I have my class intervals listed: 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. And you notice I've already got 80 to 89 now graphed, because what I did is I took the class frequency there for 80 to 89, which was 7, and then I want to make a bar graph that comes all the way up to 7, and you can see it's going right up to 7 there. Now let's take a look. 50 to 59, that was 2. So what I would want to do to graph this is I would want to draw a line, come down here, shade that all in. And now 60 to 69, that was 4. Now one thing about a histogram, you don't want to leave any space between the bars. So you notice I graphed the bars right next to each other. And so that was 4, and I'll shade that one in. Alright, 70 to 79, that was also 4. So I'm just going to draw my line right across there. Shade that one in. And 90 to 99, that was 3. So I'm going to come up here at 3. Shade that one in. And there's a histogram constructed for the grades in this history class. Now it's time to check your understanding of constructing a histogram. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 4. Construct a histogram for the grades for this mathematics test. So you can see I've got the grades listed right here. Again, I've got them organized from least to greatest. Normally you would have to do this first. But let's take a look. We've got our class intervals set up here, starting with the lowest one, 50 to 59. The next class interval, 60 to 69, 70s, 80s, and 90s. Let's start to tally these up. So in the 50s class interval, I don't have any. In the 60s, I have 1, 2. So tally that up. The 70s, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. In the 80s, 1, 2, 3, 4. And in the 90s, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. All right, now let's get the class frequency of each of these class intervals. Our lowest class interval, 50 to 59, that had a frequency of 0. 60 to 69, we had a class frequency of 2. 70 to 79, 6. And then 4, and then 6. Now let's go ahead and graph these on the histogram. So 0, or 50 to 59, we had 0, so we don't want to graph anything there. 60 to 69, we had 2. So we would make this up to 2 and shade that in, again leaving no space between the bars. 70 to 79, that's already been graphed for us. There were 6 there. 80 to 89, there was 4. So coming over here, 80 to 89, we want to graph up to 4. Shade that all in. And then 90 to 99, we have 6. So we go all the way up to 6. Shade that in. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.